Alright, so today we're going to be looking at the converse of the Pythagorean Theorem. Remember, my Pythagorean Theorem says if a triangle is right, then a squared plus b squared will equal c squared. So today we're going to look at the converse of that. So that means we need to identify our hypothesis and our conclusion. Remember, your hypothesis is everything between if and then. So that part has to be true. A triangle has to be right in order to apply the Pythagorean Theorem. If your triangle is right, then we know that a squared plus b squared will equal c squared. If the triangle is not right, then we can't apply that. Then it's not equal. Okay? So now we're going to write the converse of that. Do you remember the key word for converse? Close. Switch. Switch. So my key word for converse is switch. Okay, so we're going to switch our hypothesis and our conclusion. We're still going to start with if. But instead of starting with a triangle is right, we're going to say if a squared plus b squared equals c squared. If a squared plus b squared equals c squared. Then the triangle is right. Then the triangle is right. Okay? So I have this problem here, or this example here, where Pete claims the triangles below are right triangles. We're going to use that converse that says, well, if a squared plus b squared equals c squared, then the triangle's right. We're going to use that converse to confirm whether or not Pete's claim is correct. Now, when I look, I don't see any right angles in my picture. So that means we have to figure out, if these are right triangles, which one's going to be the hypotenuse? So here it says, if I don't know where the right angle in the figure is, how would we know which of these sides is the hypotenuse?
The larger.
Right. We know that the hypotenuse will always be the longest side, right? So if this is a right angle here, the 58 has to be the hypotenuse because it's bigger than 42 and 40, and your hypotenuse has to be the biggest side. So if we don't know where the right angle is, we know which side we're going to test as the hypotenuse, because the hypotenuse is the longest side. Okay? So when I'm looking at this first example here on the left, we know that the 58 is the longest side, so that's the one we're going to test and see, is it a hypotenuse? Okay? So I'm going to check a squared plus b squared, does it equal 58 squared? These two are interchangeable, so it doesn't matter what order you put them in. So 40 squared plus 42 squared, does it equal 58 squared? And now we can just put that in our calculator exactly the way we see it, right? So I can grab a calculator. It looks like 2 people grabbed a calculator today, so if you want to grab a calculator, come and do so. It's always good to practice in the calculator so you can practice squaring and square rooting on these calculators, because you won't have access to your phone when you take your quiz or your test to do your squaring and your square rooting. Alright, so 40 squared plus 42 squared is 3364. And then 58 squared is also 3364. So they are equal, which means, yes, this is a right triangle. That means this is a hypotenuse, which means the angle across from it is a right angle. Okay, let's check the other one, the one next door. 6, 8, and 7. If this is a right triangle, which one is the hypotenuse? 8. So I'm going to test 6 squared plus 7 squared, and I want to know, does it equal 8 squared? So 6 squared plus 7 squared, if I put that in the calculator, 6 squared plus 7 squared gives me 85. And most of us can do 8 times 8 in our head. Are those equal? No. So that means this is not a right angle. I don't know what it is, but I know it's not a right angle. Okay? So, no. Pete's claim that both the triangles are right triangles is false. One is right, the one on the left is right, but the one on the right is not. Okay? So now we have a question on the next page. It says, can we use the converse to tell if a non-right triangle is acute or obtuse? Okay? So if we want to classify a triangle that's not right as acute or, there's a typo here, acute or obtuse, we look at the biggest side just like we did when we were testing and pretend it's a hypotenuse. And then we apply the converse. We know if it is equal, if a squared plus b squared equals c, then we know we do have a right triangle. But what happens when they're not equal? So if you think about the hypotenuse, right? If I have a right angle, if I'm standing up here, my arms are in a right angle, and I have this hypotenuse, the c squared, when I put the c in, if the two sides are equal, it's a right angle. But when I put the c in, if it's not a right angle, that c is either going to be too small, and then what kind of triangle will I have? Or that c is going to be too big, and then what kind of triangle am I going to have? Obtuse. So in an acute triangle, your converse will reveal that your c, it should be c squared, that your c squared is too small to be a hypotenuse. So what that's going to look like is a squared plus b squared compared to c squared. Your c squared number is going to be too small to equal the other side. If you put an inequality, that means the a squared plus b squared is going to be greater than your c squared because your c squared is too small. Okay? The opposite is true. If you have an obtuse triangle, then your a squared plus b squared compared to your c squared is too big to be a hypotenuse. So with your inequality means the two leg sides are shorter than they should be. Okay? So you have an obtuse triangle. Remember, you can't ever trust your eyes. Okay, so if I was just going to look at these pictures and if I was told that they were to scale, I'd say this is obtuse, this is acute, this is obtuse. That one I'm not sure. That one looks like it could be right. But we can't trust our eyeballs unless it says this is to scale. So that means I need to test each of these to see if they're right triangles, acute triangles, or obtuse triangles. So it's kind of like Goldilocks and the Three Bears. We're trying to decide, is our hypotenuse too big, too small, or just right? Okay, obtuse, acute, or right. When I look at this first triangle, 10, 14, and 8, if this is a right triangle, which one would be my C value? 14. So I'm going to take 10 squared plus 8 squared, and I'm not going to put an equals there, because I'm going to wait in case I need to put an inequality there. And then my 14 squared. So 10 squared plus 8 squared, 164. And 14 squared, 196. So we always check the right side, my C squared. Is it too big, too small, or just right? Too big. It's supposed to be 164, and it's way bigger than that. So what kind of triangle is this? Obtuse. Okay. The next one, 25, 24, and 7. If this is a right triangle, which one's my hypotenuse? 25. So that means 7 squared plus 24 squared. And we want to compare that to 25 squared. 7 squared plus 24 squared is 625. And 25 squared is 625. Too big, too small, or just right? Just right, which means this triangle is a right triangle. Which one is my right angle? Is it the top angle, the bottom left, or the bottom right? The bottom right. Because this is my hypotenuse, which means this acute looking angle is really a right angle, even though it doesn't look very right. Alright, number 3, I guess, the third example. If this is a right triangle, which one is the hypotenuse? 16, 21, or 24? 24, because it's the biggest. 16 squared plus 21 squared compared to 24 squared. What is 16 squared plus 21 squared? 697, good. And 24 squared? 576. Too big, too small, or just right? Too small. So that means this triangle is acute. Alright, and the last one in this section, 15, 17, and 18, if this is a right triangle, which one is my hypotenuse? 17. So that's going to be my C value. 15 squared plus 8 squared compared to 17 squared. 15 squared plus 8 squared is 289. And 17 squared? 289. Too small, too big, or just right? Just right. So this is a right triangle. Very good. Alright, the last question, it says, can the following squares form a right triangle? So if I were to slide these squares together, they're squares, so all the sides are the same length. If I slide them together, will they make a right triangle? Okay. So I have 9, 10, and the square root of 19. Which one of those would be my C value?
10.
The 10, right? Because the 10 is bigger. It's hard to sometimes tell if it's bigger than the square root of 19, but I know it takes the square root of 100 to make 10. The square root of 19 is somewhere between the square root of 16, 4, and the square root of 25, 5. So this value is somewhere between 4 and 5, right? So I know 10 is my biggest value here, so that's got to be my C. So I'm going to look at 9 squared plus 19, the square root of 19 squared, compared to 10 squared. And really, when you put this one in the calculator, you could just do 9 squared plus 19, because I know that square and the square root are going to cancel. So it's really just 9 squared, which is 81, plus 19. What's 81 plus 19? 100. And 10 squared? 100. That's a pretty easy one to do without a calculator. Can I make a right triangle with these 3 squares?
Yes.
Yes, because these are equal, so I know it makes a right triangle. Alright, the next one I have 16, 30, and 34. So again, if I were to slide these together, would these 3 triangles make a right, or would these 3 squares make a right triangle? 16, 34, 30, which one's my hypotenuse if this is right? 34. So 16 squared plus 30 squared. Is that equal to 34 squared? 16 squared plus 30 squared? 1,156. And 34 squared? So yes or no, can I make a right triangle? Yes. These right here, when you see these problems, this is the Pythagorean Theorem in pictures, right? 16 squared, if I were to do 16 squared to find the area of this triangle, or this square, sorry, I do know my shapes. The area, 16 by 16, right? If it's a square, so length times width, 16 times 16 is 256. And my area of this one, 30 by 30, is 900. This is not to scale, right? Because this is a tiny square and that's a big square. And then the area of this square, 34 by 34, the area here, we already know 34 times 34 is 1156. If you add 256 and 900, you get this area. So really it's the area of the small square created on the leg plus the area of the square created on the other leg is going to equal the area of a square made by the hypotenuse. That's where the formula actually comes from. It's the leg, the area of the square attached to a leg plus the area of a square attached to the leg will equal the area of a square made by the hypotenuse. It's the actual Pythagorean theorem. Okay? All right, your assignment is available to you in Schoology. One word of caution. Watch your units. How many inches are in a foot? That's going to be important on one of the problems. Watch your units in Schoology.